we go. All right, so we are going to go over these problems. Number 9 showed up real late, so I'm just going to copy this over again. This is x to the third plus 2 all over x squared plus 2x minus 3 plus x over x minus 1. Okay? So, again, the back, it starts off really easy, this quiz, and it gets harder on the back. So, let's do the back together. First thing I'm going to do is I'm going to say, okay, let's factor the bottom of this. Yeah. It says to the second? It says to the second? Okay, is that better? Okay. All right, so let's factor out this bottom part. I like making the Punnett square. I think that makes more sense to me. So we have x and x. What two numbers multiply to give us -3 but add together to give us 2? 3 and -1, right? So I have x squared plus 2 on top. I have x minus 1 times x plus 3 on the bottom. Which means, what do I need to multiply this by? X plus 3, the top and bottom by x plus 3. Okay? So I'm going to distribute my x as I do it. And I get x squared plus 3x over x minus 1 times x plus 3. Okay. Now I'm going to add like terms. X squared and x squared gives me 2x squared plus 3x plus 2 all over x minus 1 times x plus 3. Now, I see that this is factored up here, like possibly I could factor this. So I'm not going to spend a lot of time on it, but I might try to see if that factors. We've got 2x squared, so I know one is 2x and one is x. And this has got to be 2, so I know this has to be 1 times 2. Okay? So I know this has to be 1 times 2. All right? But remember, I do have to make sure 2 times 1 is the only thing it multiplies by. So I have to multiply one of them by 2. So is that going to work? All right. If I have 1 here and 2 here, I get 2x and 2x. That adds together to give me 4, not 3. So if I put the 2 here and the 1 here, 2 times 2, this ends up giving me 4x plus 1. That doesn't give me 3, so this is not factorable. So I didn't spend a lot of time on it, just a few minutes. See if I could cancel anything out. All right, let's go to number 10. Now, number 10 looks a little tough because I know I'm going to have to factor both of the bottoms. Okay? So I'm going to do the one on the left side first. I like my Punnett square, x squared and 6. What two numbers multiply to give us x? That add together to give us 6.
Wait, what did you say?
What multiplies together to give us 6, but adds together to give us 5?
Oh,
2 and 3, right? 3 and 2, 2 and 3, either way. Those add to give us 5. So I've got 1 over x plus 3 times x plus 2 minus, and over here, I know I have x squared and 2, so 2 and 1 is it. That gives me 2x and 1x. Those add to give me 3. So this gives me minus 2 over x plus 2 times x plus 1. What this means, guys, is I am literally going to have to multiply this top and bottom by x plus 3. But on the other side, I'm going to have to multiply this top and bottom by x plus 1. Then we have 3 things on the bottom, but they're the same. So I'm going to end up with x plus 1 over x plus 1 times x plus 3 times x plus 2 minus, and I'm going to distribute the negative as I go. So I get negative 2x minus 6. And then I'm going to change this to a plus sign so I don't forget where my negatives go. Over x plus 2 times x plus 1 times x plus 3. All right. X minus 2x is negative x. 1 minus 6 is negative 5. Over x plus 1 times x plus 3 times x plus 2. Okay? So you didn't have to do it this way. You could have gotten 2x plus 6 and just known you were subtracting. So you'd go x minus 2x, 1 minus 6. But I like doing it this way so that I don't forget my negatives. Okay? Nothing else I can cancel out, so I can move on. So number 11 is a lot like this, so why don't we try this on our own, guys? You try it on your own, I'll try it on my own, and we'll compare our answers, okay? Ready? See if you guys can beat me. You should be doing number 11 right now.
Add 6 over x plus 3 x minus 2.
Okay. Cool. You should be trying this problem. There's a lot of talking going on, and I don't see a lot of working. Let's go. We want to be prepared for this quiz tomorrow. Shh. I don't care what you're playing today. I care that you're doing this. I want you guys to be eligible to play, so let's do this. Okay, I'm done. Who else? Gonna give you one more minute, guys, and then we'll go over it. All right, guys, let's do it. Number 11. The first thing I did was factor both the bottoms. For one, I got x minus 3 times x plus 1. The other one, I got x plus 1 times x plus 3. So the one on the left, I had to multiply the top and bottom by x plus 3. The one on the right, I multiply the top and bottom by x minus 3. Okay? This gave me 4, and I distributed. Right? 4x plus 12 plus 2x minus 6. Shh. Focus. I got one more problem to do after this, and then I'll let you work on your own. So I get 6x plus 6 over x plus 3 times x minus 3 times x plus 1. What can I take out of the top right here? A 6. So I get 6 times x plus 1 all over x minus 3 times x plus 3 times x plus 1. So I can cancel out the x plus 1s, leaving us 6 over x minus 3 times x plus 3. Okay, let's do 12 together because it's a little bit harder. Any questions about number 11 before I move to 12?
No.
Okay, let's look at 12. First thing I notice is I do not have to change the top, but the bottom I can factor. So what two numbers multiply to give us negative 24 that will add together to give us positive 2? 6 and 4, right? Positive 6, negative 4. So I'm left with 3x minus 2 over x plus 6 times x minus 4. I really expect you guys to be able to pull it together while I'm going over this. You have a quiz tomorrow. Okay, we're going to subtract x minus 3 over, does anybody know what x squared minus 16 is? With that factored out? What's the square root of x squared? It's just x, right? What's the guess? X minus 4 and x plus 4. There we go. Okay. So, whenever you have a perfect square subtracted by a perfect square, you just take the square root of them, and you have one negative and one positive. Okay, so I'm going to multiply this by x plus 6. And I'm going to multiply this side by x plus 4. Okay, now I am going to have to multiply these out, so I'm going to have to do that little Punnett square thing. I've got x and 4 and 3x and negative 2, leaving me 3x squared, 12x minus 2x minus 8. So that ends up giving me 3x squared plus 10x minus 8 all over x plus 6 times x minus 4 times x plus 4. You got to stop talking while I'm talking. It's got to end. Okay, then over here we've got x minus 3 and x and 6. We get x squared minus 3x, 6x minus 18. So I end up with x squared plus 3x minus 18 all over x minus 4 times x plus 4 times x plus 6. And now I'm going to subtract this. So again, what I like to do, guys, is change this to a plus and change all of these signs. So 3x squared minus x squared gives me 2x squared. 10x minus 3x gives me 7x. And negative 8 plus or minus a negative 18 is a positive 10. All over x plus 4 times x plus 6 times x minus 4. Again, I'm just going to take a minute or two to see if I can factor that top. 2x squared and 10. So I know one has to be 2x, one has to be 10. I want the middle part to be 7. The multiples of 10 are 1 and 10 or 2 and 5. Okay? The problem is if this one is 5, I get 10x. And if this one is 2, I get 2x, and that gives me 12x. So if I switch it and make this 2 and this 5, I get 4x and 5x. Again, none of them add up to be 7. So this is my final answer. So don't worry about this part. Just get to there and stop. So you factored them. Okay? So you factored the bottoms out. Found out what you had to add to both sides. You combined, you multiplied them out. You combine like terms. You're done. Okay? The front is easier than the back. The back's the hardest problem. The first 4 are very simple. They have the same denominator. Okay?
Oh, yes.
The next 4 are only a little bit harder. So here's my hint for like number 7 and number 8. X squared minus 9 is what factored out? We talked about it with number 12. Are these both x plus 3 and x minus 3? Right? So what's x minus 1, x squared minus 1 going to be?
Oh, 1. Wait, negative 1?
Positive 1 and negative 1. Yeah. So those are my hints for those. All right, guys, you have the rest of the hour to work on this. This will be due at the beginning of the hour.
Can I get my cellular device?
Tomorrow. Yes, you can go get your phones.
Okay. Want to eat them all night?